not recording your screen, but your the voice, right?
Yes.
Okay, so now what as I was explaining, so now this is the turning point. So the turning point, to find the turning point of a parabola, you simply say x is equals to minus b all over 2a. So then when it is in this form, you just take the value of b with the sign, you sub in, then also you sub in the value of a. So when you have something like this, the answer that you get, you're going to substitute that answer in the original equation. You sub into the equation to what? To get the corresponding y coordinate. Are you with me on that?
Yes, sir.
Right. I'll also send you the notes for this. Right. So now, my question is that, remember, this is the standard form of what? Of a parabola. This is the standard form. So we can also write this thing in the form of what? We can write this in the form of a into, we can write it in the form of a into x minus p squared plus q. Right. So my question is that, this is the one that you are familiar with, right?
Yes, sir.
Okay. So on this one, what I need you to note, my question is that, how do we move, what do we call this one? So this one, we call it what? We call it the turning point form. We call this one the turning point form. Right. So my question is that, how do we move from a standard form to the turning point form? Do you know how we convert the standard form to a turning point form?
No, sir.
We complete the squared. You understand? We complete the squared. So to move from the first one, which is the standard form, to the turning point form, we complete the squared. Right. So now let's talk about the turning point of this one. What is the turning point? Do you know what is the turning point if it is in this form?
I don't know. Is it Q? I don't know. I don't know, sir.
Okay. So the turning point.
It's P and Q.
Exactly. The turning point will be equals to what? The value of P is to Q. So that's how you find the turning point. You say the value of P. Remember that the value of P, if it's negative, you write positive. If it's positive, you write negative. Right. Then now we can write this one, the parabola, in this form. This is number 3. We can write it in the form of the x. Do you know the x-intercept? Do you know that we can write the parabola in the form of the x-intercept? Or they can give you in the form of the x-intercept. The x-intercept form, which says that y it's equals to what? It's equals to a into x minus x1 and x minus x2. So when you have something like this, we can say that, remember, on something like this, we can quickly say I have my x-intercept. So your x-intercept will be the coordinates, which is x1 and 0. Then the second one will be x2 and 0, because this is the x-intercept if y is 0. Are you with me on that?
Yes, sir.
It's very important that we discuss how you find the turning point when you have something like this. So if it is given in this form, your turning point will be equals to, we take x to find the x coordinate, we add our x-intercept, the x values of the x-intercept, then you divide by 2. Right, that's how you find the turning point. So now, another thing that you need to note on a parabola is that is that when we have, if the value of A is greater than 0, your graph will be concave up. I think you already know that. And if the value of A is less than 0, your graph will be concave down. Are you with me on that?
Yes, so if A is positive, it's smiling.
Exactly.
If A is negative, it faces down.
Nice. Well done. Well done. So now, another thing that I want to discuss with you on the parabola, then we can start with some of the examples, is the domain. The domain and range. The domain and range, this is the first part that we can discuss on a parabola function. So now, the domain, always for the parabola, the domain will say that x must be an element of real numbers. Do you know that?
Yes.
Then the range, to find the range, I'm going to give you a tip. If the value of A is greater than 0, remember your graph will be concave up, like this, right?
Yes.
Therefore, the range, we're going to say the range y must be greater or equals to q, the value of q. So you just go to your graph, then you take the value of q, which is the y coordinates of the turning point. So remember, it's the y coordinates of the turning point. So you're just going to take the value of that q. The range must be that number going up. You understand?
Yes, sir.
Then we can also write this range as what? We can also write this range as y must be an element of from q, which is not included, greater or equals to is fine, it's included. Therefore, from q all the way to positive infinity. That's how you can write your range. Right, let's assume that if you see that if the value of A is less than 0, the graph will be concave down. And if the graph is concave down, the range will say y must be less than or equals to q. Right, we just have to confirm these two. Is it greater or equals to? And also we need to confirm if it's less than or equals to. Right, then if we draw this, okay, it's fine. So now do you understand this on the hyperbola?
Yes, on the parabola, sir.
Exactly, okay. So now I want us to talk about the concavity on the graph. Remember, once you understand these questions, this theory behind the parabola, you'll understand how to answer some of the exam questions. So the concavity, but now beside the concavity, let's talk about the decreasing function of do you know when is the quadratic function is an increasing function and when is it a decreasing function? Right. So I'm just going to give you something. I'm just going to give you. Let us quickly put something on board. I'm going to draw something here. So Toriso, let's do it like this. So remember that let's say I have a graph like this. I have the value of A that is greater than 0. I know that my graph will be concave up, right? Like this. My graph will be like this, right? Can you agree with me on that?
Yes.
Right.
Yes, sir.
So always when you test for the ascending and descending function, you need to walk from left to right. You need to walk in that direction. You need to walk in that direction. So basically, you'll be going in that direction. Let us quickly put this thing so that it will be easy for you to understand. Okay. So what I'm going to do is that I'm going to say that if I have the value of A that is greater than 0, the graph will be concave up like this. Right. So remember, we have a turning point here. The X, it's also the axis of symmetry, right?
Yes, sir.
Let's put that point there. So you are walking from left to right. This is your theory. So you are going to walk left to right. You understand? You're going to walk in that direction. Can you see? So when you walk in that direction, can you see that once you get to this point, you'll be walking down the slope. Can you see that?
Yes, sir.
This tells you that when you are walking down, just know that your graph is what? Your graph is a decreasing function. You understand?
Yes, sir.
Then the moment you start to reach that turning point, the moment you start reaching this point here, then you start walking up. You are walking up uphill. So when you are walking uphill, just know that your graph is increasing function. Are you with me on that?
Yes, sir.
Okay. What I'm going to do is that I'm going to say, let's write this down. This is an increasing. Right. This is an increasing. So now, if the value of A, I'm going to give you another example. Let's say that the value of A, we have the value of A as what? As negative. We have the value of A, we have the value of A less than 0. We know that our graph will be concave down like this. Right. So remember, this is you walking from left to right. You are walking in that direction. Okay. So when you are walking in that direction, so now what you're going to do is that the moment you start going uphill, can you see that from this point, you'll start going up. Can you see that? Until you reach that point, you'll start going up. So when you go up, we said it's an increasing. Then from this point, it's up. Then when you go down, I think it's very important that we use the same color as the one that we used for down and same color as the one that we use for up. Okay, I'm sorry. Okay, I just want to rewrite this thing. Okay, we said we have something like this. This is our graph. Then this is our axis of symmetry, which is the x coordinates of the turning point. So now we said that when you go up, you are increasing. So I'm going to use red for up because it's increasing. This part going that side, it's increasing. Therefore, the moment you start walking down, you are decreasing. Right. So the moment you start going down, you are decreasing. Right. So now, when you have something like this, this is how you should expect the exam. This is how they're going to ask this question. Let's say that they give you a graph like this. Let's say the graph is like this. Right. This is the origin. And they tell you that we have the x as negative. Let's say this is -1. Right. They ask you, where is your graph increasing function? You understand? So
Yes,
they will ask you, where is the graph, where is f at x increasing? So remember, this x is -1. So the graph, we said it's increasing when you are going uphill. You understand? When you are going uphill, your graph is an increasing function. So this tells you that from this point, going that side, okay, I'm just going to, okay,